Okay, evaluate the following. So we see the integral symbol, we see the dx, that's telling us find the integral. Now this is the problem that we kind of, the foreshadowing, that, the problem that before when it was just a square, we multiplied it out. But we will note, this is a product / composition, can't simplify. And further note, the derivative of the inside function, in this case x squared plus 1, the derivative of the inside function, I'm going to put it this way, the inside function is present in the problem. Meaning this, that my inside function of x squared plus 1, the derivative of that is 2x. And that's in the problem. And that's one of the real key things that a u substitution is going to work. That when you have the derivative of the inside function, that a u substitution is going to work. Now that does not mean that if this is not present, that a u substitution is hopeless and you shouldn't even try. There are times when you can fudge things a little bit, but when you do have the derivative of the inside function in your problem, that is a real indicator. Try this thing called a u substitution. Now, like I said, it's not the only indicator, but it is a major indicator that u substitution is going to work. That I have a product and composition that I can't simplify, and the derivative of that inside function is also in the problem. Those are key indicators that I can try a u sub. Try u sub. So my steps. 1, I choose u. I think I'm going to go back up here and use my paper more precisely. 1, choose u. And again, there's not going to be an always here, but what frequently works is u equal the inside. So in this case, u equal x squared plus 3. 2, calculate du. So that's that differential that we just practiced. So you're looking at this equation right here, and then your form is du derivative dx. So in this case, du equals 2x dx. You're just working with that little equation you chose there. 3, solve for dx. So you're just looking at this equation here, solving for dx. And so what dx, and it would be du over 2x. Same first 3 steps every single time. If you can't do the whole problem, at least do these first 3 steps. Make your choice for u, calculate du, solve for dx. And so now we're actually going to do the problem. And we're going to make some substitutions. X squared plus 3, that is going to be replaced by u. Dx is going to be replaced by du over 2x. And then notice we get some canceling here. That 2x and the 2x cancel. And so when I make my substitution, I get u to the 20th du. And there is the point to use substitutions. I took a problem. I wanted to zoom out a little bit, didn't really go very far. There we go. I took a problem that was somewhat complicated looking, and I turned it into a much easier looking problem in terms of one variable. Now there is a step 5. That right now is unnecessary. We have one variable. We'll eventually get to do a problem with step 5, but that's going to be our harder problems. Once you have just one variable, then go ahead and integrate. So that's 1/21st, u to the 21st plus c. And then back to the original variable, u was equal to x squared plus 3, not 1. I put a 1 up there, it should be a 3, and I put a 1 here, and that should be a 3. And so my answer is 1/21 x squared plus 3 plus c. And we integrate that by a u substitution. Now we're going to go ahead and check it. I'll do another piece of paper. But it's always these same basic steps, especially these first 3 steps. Choose u, calculate du, solve for dx. Then you're going to do your substitution, hopefully ending up in a new integral entirely in terms of u. Then you integrate, then you go back to the original variable. And then all of this stuff can check. So step 8, check. I can check it by differentiation. I've got my 21 there. All of these are going to check with a chain rule. Because what u substitution really is, it's based on the chain rule. I mean, we didn't go through the proof of the u substitution and why it works and whatnot, but it's based on the chain rule. So all these things are going to check using the chain rule. So checking this, the coefficient hangs out, multiply by the exponent, decrease the exponent by 1. Chain rule times derivative of the interior. Very technically, a derivative of that plus c would be 0. And I get 2x, x squared plus 3 to the 20th, which was the original integrand, which you can see right up there. So all of these things will check. And there's my first u substitution. Okay, next problem. Evaluate the following. Okay, again, I'm going to note that it's product / composition. Can't simplify. And further note that the derivative of 3x squared plus 1 dx is 6x. Well, I don't have a 6x, but I have the x. And so we do have the x. And so this is a really good thing to try u sub. Okay, product / composition. Composition inside function, functions inside functions, composition. It's right here, this e to the 3x squared plus 1. That's the natural exponential function. And instead of having a simple exponent of just x, t, q, whatever, I have a complicated exponent, 3x squared plus 1. And so that's where my composition is. And so I'm going to let u equal an inside function. Or more specifically, if I go back to my list of things to try, if an exponential is involved, try u equal the exponent. That frequently is going to work with exponentials. And I did list it specifically. If an exponential is involved, try u equal the exponent. But that really is just a special case of the inside function. That e to the 3x squared plus 1, that's an exponential function where I've put something fancy inside the exponent, where I've put a function inside the exponent. So that 3x squared plus 1 is inside the exponential function. It is an inside function. So going through my steps, I choose u, and we'll let u equal the exponent. It'll give me u equal 3x squared plus 1. 2, calculate du, and remember that's just du derivative dx, where you're just looking at that line right above there. So du, then my derivative, 6x, dx, and then 3, solve for dx. And so dx will be du over 6x. Same first 3 steps every single time. And now let's do my problem. X e to the 3x squared plus 1 dx. So my exponent is going to be replaced by u. Dx is going to be replaced by du over 6x, that dx was du over 6x. And then you're going to get stuff that cancels. Now in this case, just the x's cancel, that's okay. Then that 6 in the denominator, that can come all the way out to the front as a 1/6. And all I've got left is e to the u du. And again, I've ended up with a new integral that's much easier looking entirely in terms of u. Step 5, we'll get to it later, but that's unnecessary. It's one variable. So then step 6, integrate this. E to the u is its own integral. Then step 7, go back to the original variable. Original variable was x. So I have 1/6 e to the 3x squared plus 1 plus c. And there's my answer. And we'll go ahead and check that one too. If I wrote smaller, I could get it all on one page. So step 8, check. An optional step. But like I've said, you're at the end of a test or a quiz, if we're having quizzes. If it's some non-COVID year and we're able to have quizzes in class, you can check all your integration by differentiation, all of it. So the 1/6 is just a coefficient, so it's going to stay there. E repeats, derivative of the exponent, derivative of that plus c would be 0. We get some nice canceling there. And we get back to x times e to the 3x squared plus 1. And that was the original integrand. There, we can see it all on the same page. That was the original integrand, so we know we're right. Got a few moments, check these things. And if it's the end of a test and you check and it doesn't work, you tell me that I checked this, it didn't check back. You will get more partial credit for telling me knowing you're wrong and telling me you're wrong than just being wrong. Check these things if you can. Okay, let's end this video.